All right, everybody, atomic structure. All right, so basically, as mentioned before, and this is going to be a common theme throughout all anatomy and physiology, as well as really in life, um, structure dictates function. We mentioned this earlier. I'll mention it again now. If I change the structure of something, I change its function. In other words, in the case of atoms, if I have a different structure for my atom, it'll change its behavior. What does it do? How does it react? Right? For example, if I have a person, right, and they're just walking around, right, there's no problem. But if the next day I take that same person and I toss a kick me sign on his back, I stick it on there, right, that person's going to behave a little differently because now, well, a logical person would take it off, but this person's not going to. What's going to happen is they're going to be afraid someone's going to kick them, so they're going to behave weird. You're going to see them walking down the street, looking over their shoulder every 2 seconds, like just to make sure no one's going to kick them, right? So I changed their structure. I changed their shirt. I put a stick on the back that said "kick me," and now they're behaving differently. Same thing happens with elements and atoms. And with that said, we have to look at energy levels. There's a lot of energy that's found inside of elements. If you don't believe me, then ask yourself, why do I eat food? Because the food I eat is comprised of compounds that are made of elements, right? So with that said, energy. That's a big key word we have to know. Okay. Not only energy, we have to understand potential energy. So energy allows you to do work. All right. Work can be literally anything. So for example, if I have energy, I can talk to you guys. That's me doing work. Get it? Another example could be something like your cell phone. It's got energy, so it turns on. Potential energy is the ability to do work, if that makes sense. What that means is, yeah, you have energy, but you might not be using it right now. Okay? So, for example, let's say I have my mouse. If I drop my mouse, it has energy because it's falling. All right? I can prove that because if it lands my foot, it's going to hurt. It had energy and it just popped into my foot. This mouse can also have potential energy. I can just, like, hold it there. It has the potential to fall and hit my foot. It's not doing it, but energy is stored in it because as soon as I let go, it no longer has potential energy. It now has kinetic energy, which means that it went from having potential to actually doing something. All right. You could Google those terms too if you have any other questions. Potential versus kinetic energy. Anyways, electrons. Electrons are what allow us to have that energy. Okay. The configuration or the layout of the electrons is going to determine its behavior. Meaning, if you change the way the electrons are ordered or where they are or how many you have, that's going to change the way that the element's going to react. All right. So, for example, specifically, we talk about the valence electrons. This is a term many of you have heard before. Valence electrons are the electrons, here's a picture, on the outermost shell of the atom. In the case of hydrogen, it's only got one electron and it only has one circle here, one shell. So it has one valence electron because valence means how many electrons are in the outermost shell. In this case, there's only one shell, so one. Helium has two. One, two. This is where you'll start to truly understand this. Lithium has one. Why one valence electron? There's three electrons here. It's because there's two shells, the inner one and the outermost shell. That's all I care about for valence. It has one valence electron. So with that said, these elements will behave differently. All elements behave similarly in that they need 8 electrons in order to be complete. 8 electrons on their valence shell. So on their outermost shell, if they have 8, they are happy and they're good to go and they're done. They're good. The only two that we're going to talk about that are weird, hydrogen and helium, because they only have one shell. and they can only fit 2. I'm not going to go into detail on that because you don't want to learn about that right now. But the point is, if you have 8 valence electrons other than these 2, you're good. And we call those noble gases. So one perfect example of electron configuration is this. If I have lithium, lithium will react because it has only 1 valence electron. It's going to try to combine with something that has 7 valence electrons. Why? Because 1 electron plus 7 will give it 8. So now it's going to want to react. It's going to want to combine. If you have something like argon, which on the periodic table has 8 valence electrons, it's not going to react. Hence the reason it's a noble gas. So if I took a lighter and lit up some argon gas, it's not going to do anything because it has full valence electrons. It's not going to want to react. So that's one example of electron configuration. Please watch this video multiple times, or you can find other great videos online that goes into more detail if you need it.